Good evening, sir.
Yeah, good evening, Viraj. முன்னாடி வீடியோஸ்லாம் பார்த்துட்டீங்களா இல்ல இனிமே தானா? இஸ் எவ்ரிதிங் ஓகே?
ஓகே சார். அதான் 3 நாளுக்கு பார்த்துட்டேன்.
ஓகே
நேத்துக்கு அப்புறம் பார்க்கணும் சார். நேத்தோடது மட்டும் பண்ணிக்கலாம்.
ஓகே. ஏதாவது டவுட்ஸ்
இன்னைக்கு
புரியுதா?
என்ன சார்?
ஐ மீன் புரியுதுல்ல, ஏதாவது டவுட் இருக்கா?
புரியுது சார். டவுட் இல்லை சார். அதாவது அப் டு அந்த இது வரைக்கும் பார்த்துருக்கேன் சார். அந்த
டாஸ்க் கிரியேஷன் வரைக்கும் பார்த்துருப்பீங்க.
ஷெட்யூல் அது வரைக்கும்
ஓகே
பார்த்துருக்கேன்.
ஓகே.
இன்னைக்கு எடுக்கிறது வேறையா சார்?
அதேதான். ஃப்ரீ ஆர்டாஸ்ல இன்னைக்கு நம்ம டைமர்ஸ் பார்ப்போம்.
அந்த இது வேற டெலிட் ஆயிடுச்சு சார். கரெக்ட் ஆயிடுச்சு. STM32
ஓகே. திருப்பி ரீஇன்ஸ்டால் பண்ணுங்க.
அதை ஃபுல்லா டெலிட் பண்ணிட்டு இப்போ போட்டுட்டு இருக்கேன்.
ஓகே.
Hi sir, good evening.
Good evening, Venkat.
Sir, yesterday I got a issue with power.
Okay.
Did you-
Yeah, you
could you-
informed right now.
Yes. Did you add my attendance?
Yes, I added.
Yeah, sir. Thank you.
Okay. Okay, so we'll start the class. Share the screen. Okay. So last class, I think we discussed about the task creation, okay, and task control, how to pass the arguments, how to give the handler for the task, and all these things we saw in last class, right? And we saw how to suspend a task, how to set the priority during the runtime, all these things in our extensions class. Okay. So today we are going to see another API which you are going to use in our free RTOS. Okay, so that is timer. Okay, so I'll just open this freeRTOS.org, and if you go to this API reference, you will find something called as a timer, software timers. Okay, so this is the APIs we are going to use. Okay, so there are multiple APIs for the timers, like timer creator, timer is active, start, stop, change period, delete, reset, start from ISR, and all these things. Here out of this, we will be using three different APIs. Okay, one is we are going to create the timer, and we are going to start the timer, and we are going to stop the timer. Okay, so if you want, you can use all these things like what is the period, which is currently this timer is running, or if you want to set the timer ID, okay, during runtime, you can able to do that. Or if you want to reset the timer from the beginning, you can do that. Okay, all these things you can able to do with this APIs. Okay, so I just give lunch. Okay, so first thing we are going to create a timer. Okay, so your free RTOS is actually having a separate timer. Like as I already said, we are not going to use any AL-based APIs over here, right? Only thing is for this GPIO, for this LED blinking or any GPIO, we'll be using this AL-based API. Apart from that, we'll be using all these free RTOS APIs only. Okay, and timer is again is available in both HAL as well as this free RTOS. Okay, we are not going to use this HAL based timer. We are going to use a free RTOS based timer. Okay, so in order to create a timer, okay, we'll be using X timer create. Okay, this is the API we are going to use for creating a timer in our module. Okay, and this X timer create is having 5 different arguments or parameters inside that. As like how your X task create is having an 6 different arguments, your timer is having 5 different arguments. Okay, so I'll tell what are the arguments we'll be using here. So this is the timer. Okay, so the API we are going to use is an X timer create. Okay, so yesterday I said, right, what this is mean by this X. X means it is going to return something. Okay, it can be a PD pass or it can be a PD true. Okay, or it can be something like a memory allocation failed or PD false, something like that. Okay, it is going to return something. That is what this X means. Okay, so X timer create, and inside we'll be having an 5 different arguments. Okay, we'll see one by one what are these things. So the first argument is your constant. Okay, that means in your X task create, the second argument you'll be giving something inside a double quotes, right? Okay, the same thing here in the first argument. You can give any name over here as a constant character. Okay, for example, let's say I'm just giving something like a timer number 1, something like this. You can give any name inside a double quotes. That is for our reference for the debugging purpose. That is the first parameter. And second parameter is the time period. Okay, so this timer is going to create, or it is going to start for this timer is as like your HAL timer only. We'll be having a start timer, then we'll be having an each and every count. Okay, the maximum this reload timer will be giving over there, right? After that, it will again go back to 0. It will start from this 0 to this maximum value again. Okay, this will be keep on running. So that time period you need to give. For example, if you want to run it for 1,000 ticks, just give something like 1,000 over here. Okay, so that is the second parameter. So first parameter is the constant name and second parameter is the time period. Okay, and third parameter is the auto reload parameter. Okay, I'll explain this in a moment. Okay, what this is, we will just leave this as a blank as of now. And fourth parameter is the timer ID. Okay, in your program, in real time application, you will be using a multiple timers. Okay, for example, let's say we'll be using something like in 5 or 10 different timers that will be running in different time periods. Okay, now if you want to know which timer is currently running or which timer is executing this statement, you will be giving some ID to this. Okay, that will be mostly a number. Okay, you can give any number to this. Make sure it is an unsigned number, any unsigned integer number. You can give something like an 0, 1, 2, 3, 4, whatever it is. That is your wish. That number will be assigned for this timer. Okay, for example, if you give something like an 100 and if this timer is executing, you can actually able to get the timer ID. Okay, there is an API for that. I'll show this. Here you can see, yeah, this one, PV get timer ID. Okay, so if you want to get an ID like which timer is currently being running or executing, you will be using this ID to get a timer ID value. Okay, so for that we'll be using this one. If this is currently running, it will return something like an 100. Okay, if you want to know which ID or which timer is running, you can give any number. Okay, or you can just, and this is not a unique number. Like if you assign something like an 100, you should not give 100 to the another timers. It's not like that. You can give same timer ID for multiple also. It will not throw any errors. Okay, this is for our understanding only. Okay, this is for like which timer is currently executing. If you want to know, then you will give some numbers over here, or else you can simply put 0. There is no issues. It will not throw any error and all. Okay, that is the fourth parameter. And the last parameter is the callback function. Okay, as like how your timer is having an function. Okay, yeah, as the first argument, here we will be having something like a function at the last. For example, I will give something like an timer 1. Okay, and we will create some functions for this, all these things. Okay, that can be done later in the void time 1, something like that will give. Okay, so that is the parameters, 5 different parameters. In that we didn't see the third parameter. Okay, third parameter is like before going to this third parameter, we just want to know there are 2 different timers available in the free RTOS. Okay, so free RTOS timers. Okay, one is one shot timer. Okay, and the next one is auto reload timer. Okay, so there are 2 different timers available, one shot and auto reload timer. One shot timer is, for example, here you are giving 1,000, right? That means 1,000 ticks. Okay, if you give one shot timer, that means after 1,000 ticks, it will execute only once. Whatever you are giving inside this function, okay, that will be execute only once after 1,000 ticks. Okay, that is what this one shot timer is. Whereas auto reload timer means for every 100 ticks, this function will get executed. Okay, so once it reaches 100, so 1,000, it will become 0 again and start from 0 to 1,000. Again, it will execute this timer 1. Again, it will become 0. Okay, this will be keep on running. That is an auto reload timer. And one shot timer means it will execute only one after this time period. Okay, that is what an one shot timer and auto reload timer. And how we are going to define whether this timer is a one shot timer or an auto reload timer is, that is what this third parameter is. Third parameter, we will give something like an PD true and PD false. Okay, so if you give something like an PD true, yeah, so if you give something like an PD true, that means PD true, Okay, that means this is an auto reload timer. Okay, so this third parameter is nothing but whether it is an auto reload timer or not. That is what this third parameter is. If you give true to that, that means it will work as an auto reload timer. Or if you want to use a one shot timer, you just put it as an PD false. Okay, so this PD false is for the one shot timer and PD true is for the auto reload timer. Okay, so that can be defined on the third parameter. Okay, so first one is the constant name, any string you can give, and second one is the time period. Okay, and third one is whether we are going to use this timer as an auto reload or one shot timer. Okay, and fourth one is the timer ID, and fifth one is the function. Okay, then we'll end with the semicolon. Right. So this is what an X timer create API. Okay. Now this X timer create will return null. Just write in a different color. It will return something like a null if this timer is not created. Okay. So if the timer is not created, that means it will return null. Not created due to some memory issues or anything. Okay. If it is not created, then it will return null. Since it is an X, that means it has to return something, right? Okay, so we will get null. So once you created this, we will check whether it is a null. If it is null, then we will print timer is not created, or else we will start the timer. Okay, how to start a timer is the second thing. So this is for creating the timer. Okay, we have only created the time, we didn't start the timer, right? If you want to start the timer, then you will give another API which is called as an X timer starter. Okay, so this one. Okay, so X timer start. Now this X timer start is going to get two parameters. Okay, one is the timer handle. Okay, so where we will give the timer handle is we will give a timer handle over here. For example, let's say T1 handle, which is equal to this X timer create. Okay, so this T1 is nothing but it is an handle. Okay, we will see in the example. So here we will giving I need to start this timer number 1, and second parameter is the block time. Okay, block time means, for example, you don't want to start this timer instantly, like when you click run program. Okay, this timer should not start instantly. Instead of that, I just want to start this something like after 5 seconds this timer has to start. Okay, then you can give that in the block time. For example, if you give something like an 5000 ticks, okay, and whenever you are running the program, like when you click that resume button, it will wait for 5000 ticks. After 5000 ticks, this timer will start. Okay, and then it will wait for a further 1000 ticks. Okay, so that is what this block time is. This timer itself will start after 5000. Then after starting, it will just start from 0 to 1000. After 1000, it will execute this timer. Okay, that is what this block time is. Okay, if you don't want this block time, if you want to start your timer instantly, then you can directly give something like a 0 over here. Okay, that means this timer will start instantly. Okay, so that is X timer start. Two parameters. One is which timer I need to start, and is there any block time? If there is a block time, how much time I need to wait for starting this timer. Okay, that is the second API, right? And the third API is if you want to stop the timer. Okay, then the same thing again. So just give X timer stop, again the same parameter, which timer I need to start, is there any block time. Okay, so just give the same T1, and block time you can just give simply 0. If you want to stop it, you can just stop it instantly. Okay, if you give something like any numbers over here, like something like, let's say the same 5000. Okay, so what will happen after 5000 ticks, the timer will get stopped. Okay, So that is what the start and stop differs. Okay, so this block time means how much time I need to wait for executing this API. That is what this block time is. So we will be using these three APIs. One is for creating the timer, and one is for starting the timer, one is for stopping the timer. Okay, so these three APIs we will be using in our program for two different methods. One is for one-shot timer and the next one is for auto reload timer. Okay, so clear with this one?
Sir, can you explain once again that one shot and auto reloaded?
Okay.
Shortly.
So one shot means here we will be giving a time period, right? That means 1000 ticks I have given over here. Okay, let's assume it is in 1 second. Okay, now if you give this timer as a one shot timer, once this timer starts, after 1 second, this function, whatever you are given inside this function, that will be execute for only once. Okay, that is a one shot timer. Okay, after 1000 ticks, this function will execute once. After that, it will not execute again. It will just stop there. Auto reload timer, for each and every 1000 ticks, this function will get executed.
Okay, like again up, then again down, again it will go
Yes,
to up,
yes.
then again.
So it's like this one. Okay, it will go to reach 1000. After that, it will come down. Again, it will start from 0. Again, it will come down. Okay, this is for the auto reload timer. Whereas one shot timer,
Okay.
it will just go there and it will just stay there. That's it. Okay, so that is auto reload and one shot timer difference. Clear?
Yes.
Okay. Anyone, any other doubts? Okay, so we'll create a project for I'll just close this one. Okay, so I'm just going to create a project. Okay, so this is F334 board, and these are same steps. First, we will see the one shot timer. Okay, so I'm not going to do anything with this. I'll go to yeah, FreeRTOS kernel. So you're familiar with this step, right? Like how to copy and paste the
Yes,
folder
sir.
and configure. That is clear, right? Okay. So I'll paste this. So this is FreeRTOS kernel, right click properties. I'm including that. Again, properties, C++ build settings, include path. Here I'm just going to include this. Okay. So one shot FreeRTOS. Okay, so include ARM-CM4 and memory management. These three things I'm going to include as a path. And after that, I'm just going to this RCC. This is bypass. This is crystal ceramic. And here I'm just going to use the timer 3. and this NVIC 4-bit preemption, code generation, system tick, pendable request, and system service. I'll just generate the code. Yes. So I'll build this to make sure it is 0 error and warning. Yes, it is. Okay, so now I'm just going to open my ITM code for this printf statement. I'll open this src system call, paste ITM syncar. I'm just going to paste it here. Okay. Yes. No. Open. Copy. Okay. Function. Okay. Okay, so this is done. I'm just going to close this. Here we are going to write our code. Okay. Now, in order to use this timer in our code, okay, or this timer APIs, just a minute. Start. Yeah. So in order to use the timer, we need to use timers.h header file. Okay, so in our previous example, we have include free.rs.h, task.h, right? Similarly, here we need to include timers.h for using this timer based APIs. Okay, so that is one thing we need to make sure. Okay, so in this include, I'm just going to give first one hash include free.rs.h, again hash include. We are not going to use any task over here, but let's just put it as it is. Okay. So here I'm just going to put a timers.h, and for printf statement, I'm just going to put hash include stdio.h. Okay. So I'm just going to add, so this one is not mandatory, this task.h. Okay. Even if you leave this, that will not be no issues, but like we are just using it for every functions, right? I mean, every project, so I'm just giving it as it is. Here we are not going to use any task. Okay. We are not going to create any task over here. So that is okay. So this is I have included all these header files. That is fine. And the next thing is I'll directly go to the private variable. Okay. Here I'm just going to do as like what we did for the task handle. I'm going to create an timer handle over here. Okay, because I need to create a timer with an handle. Okay, this handle only I'm going to start it over here. Right. So I need to create an timer based handle. So I'll just give something like an in private variable. I'll give timer handle underscore t. Okay. Here you can give any name. For our understanding, I'm just giving it as an one shot timer. Okay, you can give any name for that. Okay, it need not to be an one shot or something like an auto reload. I'm just giving a none. Okay, so it is one shot
Sir.
timer with
So timer handle what?
It's a pointer, sir.
Which one? It's not a pointer actually.
Okay.
It is a handle. Yesterday we created for the task, right?
Timers.
உங்களுக்கு இல்ல actually அரவிந்த் சொல்லிட்டு இருக்கேன். So Arvind, yesterday we created for the task, right? The
Yes,
last
sir, yes.
parameter we have created an handle. Okay, the same thing we are going to create an handle for a timer.
Okay, sir.
Okay, so for your
Okay.
this handle is nothing but using this handle only we are going to control anything. Okay, so in our device driver also, you might have seen something called as an UART handle, like I2C handle, SPI handle, right? We are going to configure that UART, or we are going to get a value of that UART through this handle only. It is like a gateway. Okay. So similarly, we have something like a task handle. Yesterday in our example, we saw the task handle. Okay, you just watch that video later. So task handle is for doing some control with the task. Like we can able to delete a task, we can able to suspend a task, we can able to set the priority of the task. Okay, all these things we can done through that handle name. Okay. Similarly, here we are going to create a timer. We are going to start a timer. We are going to stop a timer through that name. Okay, we need some name for the timer. That name is called as an one-shot timer. Okay, and it has to be timer handle. That's it. So timer handle is an inbuilt structure. Okay. So here, if you just open, no, it is already created. Okay. If you just right click and open declaration, you will see the structure one.
Object or variable.
டைமருக்கு ஒரு நேம் மாதிரி வச்சுக்கோங்களேன். ஓகேங்களா? இப்போ இந்த டைமர் நான் என்ன பண்ணணும் அப்படின்னாலும் அந்த நேம் வச்சு தான் பண்ண முடியும். இப்போ ஒன் ஷாட் டைமரை ஸ்டார்ட் பண்ணு, ஒன் ஷாட் டைமரை ஸ்டாப் பண்ணு அப்படின்னு நான் சொன்னேன்னா அந்த அந்த டைமருக்கு ஒரு பேர் வேணும் இல்லையா? அந்த பேர் தான் ஒன் ஷாட் டைமர். ஓகே, அந்த டைமரை இதுதான் ஹேண்டில் பண்ண போகுது. அதனால தான் பேர் டைமர் ஹேண்டில். ஓகே. Okay, so I created a handle for this one shot timer. Okay, now what I'm going to do, I'm just going to this user code begin to here. Okay, now using this handle name, that is one shot timer, I'm just going to create a timer. Okay, so one shot timer, that handle name, whatever the handle name I have created over here, same handle name equal to x timer create. Okay, now this x timer create will ask 5 different parameters. Okay, as like what we discussed here. So I'm just going to give something like this is an one shot timer. Okay, and the time period I'm just going to give 1000. And the third parameter is x auto reload. Whether this one is an auto reload or not, it is asking. Since it is a one shot timer, I just need to give something like an PD false. Okay, so PD false means this auto reload is a false. That means it is a one shot timer. Okay, and it is asking the ID. I'm just giving it as a 0. Okay, I'm not going to give any ID. And this is a callback function. As like our timer, once this 1000 ticks expired, it has to go somewhere and do some operation. Okay, so that is what this callback function is. Okay, you can give any name for this callback function. I'm just giving it as an one shot callback. Okay, so this name can be anything. It's need not to be something like in one shot, all these things. Okay, so after this one shot created, what I'm going to do, I'm just going to check whether this timer is created properly. Okay, so I'm just going to give if this one shot timer, if it is not equal to null. Okay, if it is not equal to null, that means it is created properly, right? Okay, so I'm just going to put a printf statement. Printf statement, the timer created successfully. Okay, /r/n I will give. Okay, so if this timer is properly created, then print this timer created successfully. After that, start this timer. Okay, so I'm just going to give x timer start. Okay, so it will ask which timer I need to start and what is the tick. The timer name is this one shot timer, the same thing. Okay, so one shot timer, comma, how much time I need to wait. Don't wait, just start it whenever I create an resume button. Okay, So I have created a timer with all this parameter. Then I'm checking if the timer is created properly. If it is created properly, I'm just printing timer created successfully, and then I'm starting the timer. Instantly I'm starting it. Okay. After this, I'm just going to start the scheduler, because after any operation, we just need to start the scheduler. The task stuff scheduler. Okay. Because scheduler is the one who is just going to do all this operation. We need to start it. Okay. So that is the timer creation. All right. So I have done everything. The only thing that is left is I need to give what this one shot callback has to do. Okay, that is the only thing left. So for this, as usual, I'll just go to this user code begin 4. Okay. Inside this, I'm just going to give what this function has to do once this time period is expired. Okay, so that I need to give over here. So I'm just going to put void this one shot callback. Okay, the same name whatever I have given. Inside this, for our task creation, we will be sending some values as a parameter. Correct? We can send an string, or we can send a number. Okay, so that it has to be void pointer. After that, we can convert this void pointer into the character pointer or integer pointer by doing a typecasting. So that example we saw yesterday, right? Here, what we will get is we will get the timer value or timer, what to say, actually timer value will be getting as an argument for this one shot callback. Okay, for that, which has to be the timer handle data type. Okay, so instead of this void pointer, we will be giving for the task. Here for the timer, this timer has to get the timer value. Okay, so it can be any name. I'm just giving it as a timer 1. Okay, but it has to be timer handle only. Right. So inside this timer handle, usually what we will do inside this function, we'll be giving this while of 1, right? Here, since it is a timer, we should not give any while of 1. Okay. So instead, I'm just going to just put what this function has to do. So I'll just put it is an one shot timer, or I'll just put it as an inside one shot timer. Okay. So this is slash r slash r. Okay, so I'm not going to do anything. If you want, you can turn on your LED or something like that inside this function. Okay, so that is your wish. For that, you just need to configure that in the IOC. Okay, I'll just do this. If you want, I'll just make this as a GPIO output, and then I'll generate the code. Okay, so now inside this callback function, I'm just going to toggle this one, al underscore GPIO underscore toggle pin of this A5. Okay, after this, I'm just giving inside one shot timer, something like that. Right? Okay, so that's it. And the only thing left is I just need to declare this function on the top. So I'll just copy that and I'll go to the private function prototype. Okay, I'm just going to paste it. Okay, so I'll build to check if there is any error. Okay, there are some 3 errors. What it is?
So it's equal to null for
Which one? Which one? This one. Okay,
yeah.
initially
That's
this, there is nothing
it,
over there.
it's not a pointer. No, that's what I thought is null. Why?
This one. You can give this. It's a pointer only. Timer handle. Your timer handle is a pointer. See, that's why I said, if you want to know this, what it is, just right click and go to open declaration. There they will give this, what this API is declared as. Okay.
Yes.
Yeah. There are some 3 errors. I just want to check what it is. Okay. So there is some thing over here. Okay. If you want to use this timer, just go to this FreeRTOS kernel folder. There is an include folder, right? Just go over there. There is an FreeRTOS config.h. I think we already explored this FreeRTOS config.h for preemption and cooperative method. Okay. Just open this. There, if you just scroll down, by default, your timer is actually disabled. Okay, config use timer, it is actually 0. Okay, if you want to use a timer, just make this as 1. That's it. Okay, so that's why it is saying there is no such timer is created, something like that. So make it as 1 and then build the code. Okay, there will be 0 errors and warning. Okay, so what other thing we are using, we just need to enable that in the configuration file. Okay, for your FreeRTOS, that's it. Right, so this code is done. Now I'm just going to connect my board and we will see what output we are getting. Today I'll finish this class earlier because I just want to, there is a new batch started yesterday. Okay, I just want to give some introduction to them. So I'll just finish this class after the auto reload timer. Okay, I'll just finish this class today soon. Okay. Right, I'm just going to right click this, debug STM32C C++ application. Here debugger. Okay, I'm just going to enable the serial wire viewer. All these things we already know. Just click OK and it will switch. Okay. So this is my ITM data console. We are inside a debugging mode. Okay, so I'm just going to configure it as port number 0. Okay, and then here I'm just giving a start trace. So after that, I'm just going to give a resume. You can see timer created successfully has been started instantly. After that, 1 second inside one shot timer that will be printing. Okay, that is after 1000 ticks. Okay, if you want to see that clearly, I'll just give some more time. Let's say I'm just giving it as an 5000 ticks. Okay, I'll just relaunch. Okay. Switch data console. Okay, you can see over here, when I click this resume, the timer created successfully will be instantly printing. Okay, like when once this timer is created, this will be printed. Okay, after 5 seconds, that means we are starting the timer, and after 5 seconds, that callback function will be executing. Okay, so that is what the program is. So I'll just create this resume. You can see the timer created successfully is printed. Okay, it will wait for 5 seconds or 5000 ticks. After that, it will execute this callback function only once. Okay, because it is a one shot timer. That means after the time period, this function will be called once. After that, it will stop automatically. Okay, so that is what an one shot timer is. Clear? Any doubts in code or anything?
No, sir.
Okay. So just copy this code. These things. Just let me know once you are done. I'll just scroll down the code.
Sir, I'm getting errors, sir. Terminate
Like where?
free RTOS project transfer. This is config system call stack size
Okay.
undeclared here.
Okay. Can you share the screen?
Yeah.
Yeah. Config system call stack. Okay. I have given one zip file, right, for you people in the group.
Yes, sir.
Use that one
Oh,
for the free ATA scholar. Okay. Yeah. Do you have that, or do I need to send it again?
I have, sir.
Okay. Okay.
Sir, port macro.h is not available. It's,
Port macro.h is not available. Okay, that means you didn't include that folder.
okay.
Right click that folder and uncheck that exclude resource from the build. Or add the path properly. Yes, so that might be the issue. Others? Are you doing it? Can I scroll down the code? Mohammed, is it clear?
No, sir. Again, I'm getting different errors.
Okay. Can you share it again?
Yeah.
Undefined reference to X timer create. Okay, open this FreeRTOS kernel. Go to include configuration.h FreeRTOS config.h. No, just double click that. Scroll down. Okay, here line number 76. Make it 1. Yeah, save the file and then build it again. Okay, so yeah, there is a multiple definition. That means you need to open this IOC file and uncheck those 3 parameters.
Sir, this is correct, sir. High speed clock and low speed.
You're using 446. Yeah, okay. Go to NV. Just press Control M. No, Control M, not N. Okay. Click code generation. Okay, just click and drag that configuration to the top. Okay, on the right side you are getting, yeah, that's what. Not that, system tick, pendable request, scroll up, system service. Okay, that's it. Control S. Okay. Right. Yeah, done. Okay, so others, are you getting output? Shall we go to the next project? The auto reload timer.
Okay, sir.
Okay. So I'll create a new project. Next, this is auto reload timer. or I'll just give RTOS underscore timer. Okay. So in this project, we will just create both the timers, like one shot timer as well as the auto reload timer. Okay. We'll see how this auto reload timer has to be created, and we can use multiple timers also. Okay. So all these timers will start instantly, right? Since it is in parallel processing or multi-threading. Okay. This will all these timers will start instantly, and it will if you want to execute any task for a given frequency, accurate frequency, three different frequencies, something like that. Okay, then you can use this one. For example, if you want to blink three different LEDs in three different frequencies, like one has to be executed in 250 milliseconds, one has to be executed in 500 milliseconds, and one has to be executed in 1000 milliseconds. You can create three different timers, and you can just assign the LED to that. Okay, and each and every LED will be blinking exactly in that time period, right? So I'll just create the, sorry, I'll just close the other projects. Okay, so I'll do the same thing. I'm just going to copy the free RTOS. I'll paste it here. This one, exclude, apply, properties, add, apply and close, rebuild. Okay, the next one is I'm just going for this RCC. This is bypass. This is crystal ceramic. This is timer 3. And in NVIC, 4th generation, system tick, pendable request, and soft system service. Yes. Okay, this is done. I'll just build the code. There are 11 errors for TM32 XX HAL timer is not found. Okay. System
4-bit
பண்ணியாச்சு.
அது எதுக்கு சார்
RCC.
பண்ணணும்?
This is for the preemption. Like if any new task comes, okay, it has to be preempted. ஓகேவா? இப்போ கரண்டாக ஏதோ ஒரு லோ ப்ரியாரிட்டி டாஸ்க் ரன் ஆகிட்டு இருக்கு அப்படின்னா, இப்போ நியூ ப்ரியாரிட்டி டாஸ்க் வரும்போது இட் ஹாஸ் டு கோ தேர். ஓகே, ஸோ அது எத்தனை டாஸ்க் வரைக்கும் வி வில் பி டூயிங்னா வில் பி யூசிங் ஃபார் 4-bit ப்ரிஎம்ஷன். தட் மீன்ஸ் 0 to 15. ஓகே, 15 டிஃப்ரெண்ட் ப்ரியாரிட்டிஸ் இருக்க டாஸ்க் வரைக்கும் நம்ம இந்த மாதிரி பண்ணிக்க முடியும். ஓகே, அதுதான் இந்த 4-bit ப்ரிஎம்ஷன். சிஸ்டம் சர்வீஸ், பெண்டபிள், சிஸ்டம் டிக் டைமர். ஓகே, டைம் பேஸ் கொடுத்தாச்சு. வேறு எதுவும் ஓப்பன் ஆகல. RCC, bypass crystal ceramic, system tick timer la I have given timer 3. Everything is fine. Okay.
Sir, I have created new project that IOC file is not coming.
IOC file is not coming.
Hmm.
I mean, are you getting all these files? Only this IOC file is not coming up.
Yeah, correct.
Why it is so? Like, have you tried another time? No.
Yes,
Okay,
sir.
try it.
Second time. Okay.
Second time also same thing.
Yes.
But it has to come. Okay. Share your screen.
So shall I delete and create again?
No, just create new project. Leave it as it is. Just right click this. No, right click that project. Close unrelated projects. Okay. And again, right click, close project. Okay. Now go to file, new STM32. Okay, select the board. Next. Okay, see here you are not getting this target project type as an STM32 cube. You are getting an empty. Okay, this problem we already got in the last week, right? In the device driver. So just
we need to
cancel.
update.
Yeah, you need to update it. Cancel this. Go to help, about. You're using 19 version only. Then why it is? Okay. Where is the previous project? That timer. We have done that in the same thing now. Okay. Open that. So yesterday it came, right? Today only it's not coming.
Yes, sir.
Okay, we will try that one. No issues. Okay, you can just edit this here itself. Okay. Again, just update it once this class completed and then restart and again check it. Okay. So meanwhile, just
Okay.
do some edit in the same thing. Okay. I'll share my screen. Okay. So now we are going to create two different timers. One is an one-shot timer, one is an auto reload timer. Okay. So for that, first I will just give all these header files. Like first one, it is an hash include this free RTOS.h. Okay. And we'll have hash include task.h and we have hash include timers.h and we have hash include stdio.h. Okay, so I'm just going to build this. Yeah. So in this private variable, I'm just going to create two different handle for this timer. Okay, just give timer handle underscore t. One is my one shot timer, okay, which is equal to null. And again, this is a timer handle. Let's put this as an auto reload timer. Okay, I'm just going to make it as null. It can be any name. It need not to be auto reload. Okay, auto reload or a one shot timer. It can be anything. Okay, I'm just giving it for my understanding. Okay, so now in this user begin code to first one shot timer, which is equal to x timer create. Okay, so inside this, I'm just going to give one shot timer in the double quotes. Then ticks is I'm just giving 1000 ticks. Auto reload timer. This is PD false. Okay. And timer ID I'm just giving 0 and callback function I'll just give one shot callback. Okay, that's it. Right? This is for one shot timer. Similarly, auto reload timer equal to, I'm just giving X timer create of, this is auto reload. Here I'm just giving an 1000, same thing. We will see difference what is happening here. Okay. And in this auto reload timer, since it is an auto reload, I'm just going to give PD true. Okay, that is the only difference between the auto reload timer and one shot timer. Here you have to give PD false for one shot. Auto reload, it has to be PD true. That's it. And timer ID, you can give different ID or same ID. There is no issues. Here I'm just giving the same ID for, I'll show you, it will not throw any errors or something like that. Okay. So this is auto reload callback. Okay. After that, I need to check whether both these timers are created properly. Okay. For that, I'm just giving if this one shot timer, if it is not equal to null, and also, okay, this auto reload timer is also not equal to null. Okay, both the timers are not equal to null. That means both the timers are created properly, right? So I'm just going to put a printf statement with both timers created successfully. Okay, I'm just giving /r/n. After that, I'm going to start both these timers. Okay, for that, I'll give X timer start. Okay, it will ask which timer and how much time to wait. First one is I'm going to start the one shot timer instantly. And also I'm just going to start my auto reload timer instantly. Okay, once this timer is created successfully, I'm just going to print it and then I'll start the timer. Okay, one timer is a one shot timer and another timer is an auto reload timer, right? So now I'm just going for this user code begin 4, okay, for creating the timers. Okay, so first one is a one shot timer. This is again timer handle. I'll just give something like a timer 1. Okay, you can give any name. So inside this printf statement, I'm just printing this is one shot timer. Okay, so /r/n. And here again, I'm just copying this and I'll paste it. Make sure it is an auto reload callback. Okay, make sure the spelling is correct. So just double click it so that you can able to see if this is also highlighted. That means both the spellings are correct. Okay. Like wherever you are given this auto reload, all this time, all this statement will be highlighted so that you can check both the spellings are correct. Okay. Now this is auto reload timer. Okay, that's it. So make sure this is something like a timer 2. Even you can give timer 1 also, that it will not throw any error. But if you want to do some other operations with that timer, you can give different name over there. So this is private function prototype. I'm just going to declare both these functions. Okay, so one is timer 1, one is timer 2, and this is my auto reload. Okay, that's it. So I'll just explain it once again what I have done. First, I have created an header file for FreeRTOS task. Here I'm going to use a timers, so timer.h and the stdio.h. Okay. And here I'm going to create two different handles. One is for one shot timer, one is for an auto reload timer. Right. And then I'm just going to create two different timers based on this handle. One is one shot timer for creating the same 1000 ticks. This is a one shot timer, and auto reload timer. I'm just giving it as an auto reload timer for same 1000 ticks. Okay. I'm checking whether these two are created successfully, and then I'm printing it. After that, I'm just starting the timers, both the timers, auto reload and one shot. Okay. Once it is done, I'm just printing one shot timer, and this is auto reload timer. That's it. Okay, we'll see the difference. What is one shot timer and what is auto reload timer? There are 5 different errors. Okay, again the same thing. I just need to go to this include config.h, and this one has to be what? Done. Okay, I think I didn't copy and paste this over here. Yes, I did. Okay. I'm just copying and pasting this ITM code. Right. I'm just going to paste it. That's it. So build. Okay, no errors and warning. My board is connected. So I'm just giving like click debug STM32. This is debug. I'm just going to enable the serial wire viewer. Okay. Switch. This one config port 0. Okay. And start this. Okay. Now, if I click this resume, okay, we will get 2 timers that will be instantly started. Okay. First, I will get both timers created successfully, and then both this timer will start instantly. Right. So what will happen is, first one shot timer will execute only once after this 1 second, and your callback, your auto reload timer is going to be execute again and again for each and every 1 second. Okay, that is what we are going to see. So I'll click resume. You can see both timers created successfully, but the timers are not executing. Did I miss anything? Sorry, I didn't start the scheduler. Okay, it's my mistake. Okay, after this timer start and everything, I need to start the scheduler, right? So we task start scheduler. Okay. So build and again debug. Switch STM data console, and if I give resume, yeah, you can see this is one shot timer that is executing only once. After that, each and every 1000 ticks, this is auto reload timer will be executing. Okay, so that is the difference between auto reload timer and one shot timer. Auto reload timer, for every that time period whatever you are given, it will be executing again and again. Okay, whereas one shot timer, for that time period it will execute only once. Okay, so that is the difference between auto reload and one shot timer. Clear?
Where we will use this, sir? Like,
If you
like,
want any task to be periodically
any
executed.
applications.
Okay, for example, in any safety applications, if you want to execute or if you want to check periodically after some 1 minute or a 10 minute, we just need to periodically check every sensors whether it is working correctly. Okay, then we will give this
For
timer.
any getting status, frequently
Yeah,
we are
status
getting
also. Yeah,
status,
frequently
check
for
status
any time
status.
periods, any frequencies. Accurately, if you want to get that, you will be giving this timer. Okay, without
Got it.
without interrupting other tasks. Okay, if there is any high priority task comes, it has to prefer there. Okay, so that is the main thing in FreeRTOS. Okay, none of this task, none of this timers or a queue or a semaphore, whatever we are going to see in our remaining classes, everything works based on the priority. Okay, if even though this timer is running in the background, if any high priority task comes, it will go there, it will attend that one. Okay, it will not wait for this timer to be completely expired. Okay, that is the main thing in FreeRTOS. Okay. Yeah, copy this code. The same thing like what we did in the previous program. Just create one more handle. That's it. And then create two different timers and start it and do all these operations.
Sir, completed, sir.
Yeah. Have you got output?
Yes, sir.
Okay. Others?
Yes, sir. I do.
Okay. So this is the timer in FreeRTOS. Okay. So if you want any task or anything to be periodically executing, or after some time, if you want to check it only once, then use this timer based on your application, whether it is an one shot or an auto reload. Okay. So in our next class, we will see the queue. Okay, how to create a queue in FreeRTOS. Okay, how to send data to the queue, how to receive the data and print it. Okay, all these things we will see in next class. Okay.
It's like a one task to another, like task we are sending the data by using queue.
Yes. Not one task to
It's like
another
a one
task.
process to another process. Like
You can send in one task and you can receive in another task.
another task. Yes, sir.
Yeah.
That's what
Yeah,
the queue
that you can do.
purpose.
Yes.
Yeah. So is that file operations or like memory based?
It's a memory based.
Okay.
Okay, that we will see tomorrow, like what are the APIs available and how to create it, how to send and receive the data, all these things we will see tomorrow. Okay. So yeah, so thank you. We'll see tomorrow. Okay.
Thank
Bye.
you, sir.
Yeah, thank you. Bye.
Thank you, sir.
Thank you. Bye.
Thank you, sir.
Thank you.